Welcome! Today we're diving into something pretty cool, how to make sense of huge amounts of data. We're going to see how data visualization is way more than just making pretty charts. It's actually one of the most powerful tools we have for turning complex information into something crystal clear. So you've got this massive database, right? And you just know there are incredible insights hiding in there. But the data doesn't just give up its secrets easily. The big question is always, how do you actually get it to talk? How do you make it tell you its story? Because let's be honest, without the right tools, a giant data set isn't an asset. It's just a wall of noise. The sheer volume of it can be completely overwhelming, and it's almost impossible to spot the really important patterns that are buried deep inside. Okay, so let's start by really digging into the core problem here, the challenge that data visualization was basically invented to solve. Back in the day, the classic advice was always to get familiar with your data. And what that meant was literally scrolling through spreadsheets row by row. But with the kind of data sets we have now, it's not possible anymore. Those old methods just don't work. And that's exactly why visualization has become so incredibly essential for any real analysis. So, if we can't just scroll through our data anymore, what's the game plan? Well, this brings us to a really powerful guiding principle, a kind of mantra for how to navigate all this complexity. It's called the information-seeking mantra, and the core idea here is to completely change how we think about this process. Visualization isn't just about making a final chart for a report. It's about turning your analysis into an interactive journey, a real voyage of discovery. And the mantra itself? It's beautifully simple. It's 3 steps. First, you get the big picture, an overview of the entire data set. Then, from that high level, you zoom and filter, homing in on the parts that catch your eye while clearing out all the clutter. And finally, when you've found something promising, you ask for details on demand, drilling down to get the exact numbers you need. Now, the secret sauce that makes this whole thing work is interaction. You're not just staring at a static picture. You're actively having a conversation with your data. You're zooming, you're filtering, and you're using these really powerful techniques like linking and brushing, where clicking on data in one chart instantly highlights the related data in all your other visuals. It's totally dynamic. Okay, so we've got our strategy down. But what happens when your data has dozens, maybe even hundreds of different variables? How in the world do you visualize that? Let's get into the techniques for seeing in high dimensions. It really boils down to 2 main approaches. On one hand, you have geometrically transformed displays. This is where you use clever math to kind of squish all those dimensions onto your flat 2D screen. And on the other hand, you have iconic displays, which is a totally different idea. Here, you turn every single data point into its own tiny icon, and the features of that icon, its shape, its color, its size, are all driven by the data. And this iconic approach can get really creative. You can have star icons where each point's length represents a variable, or even little stick figures where limb angles are controlled by your data. Probably the most famous example, though, is Chernoff's faces, where data variables control facial features. This lets you spot outliers because they literally look like an odd face in a crowd. Now, here's the crucial part. When you plot thousands of these little icons, you're not supposed to analyze each one. Instead, they all blend together to create a visual texture, and our human visual system is amazing at spotting changes in texture. A sudden shift in the underlying data becomes a visible break in the pattern, something our brains are just wired to notice instantly. All right, so now that we have these techniques, let's connect them to some common data mining tasks. How does actually seeing the data help us make sense of the analytical models we spend so much time building? So let's start with classification. Say we've built a model to predict something, like customer churn or fraud. How can visualizing it help us understand and maybe even trust what it's doing? Well, a perfect example is a decision tree. Instead of trying to read through a long, complicated list of if-then rules, you can just look at the tree itself. You can immediately see the logic, the splits, the flow. It makes the whole model transparent. Or think about visualizing a confusion matrix. You can instantly see where your model is nailing it, and more importantly, where it's getting confused. Okay, so that's classification. But what about clustering? When our goal is to find those natural, hidden groups that exist in our data. For clustering, visualization is, and I mean this, absolutely critical. An algorithm can tell you, hey, I found 5 clusters. but it's only when you actually plot them that you can see if they're real, distinct groups. It lets you understand their size, their shape, and you can see how much they overlap. It gives you a much, much better feel for the quality of your results. And for our last example, what about association rules? The whole people who buy diapers also tend to buy beer kind of analysis? How does visualization help there? See, a market basket analysis can spit out thousands upon thousands of rules. And frankly, most of them are just noise. Visualization lets you plot all of them at once. You can map metrics like support and confidence to different axes, and boom, the strongest, most interesting rules just pop right out. You can spot relationships that would be completely lost if you were just staring at a spreadsheet. So let's wrap this all up and recap the really powerful tools we've just added to our analytical toolkit. Okay, so here's the bottom line. First, we have to start thinking of visualization as a core tool for discovery, not just for presentation at the end. Second, we have a roadmap for that discovery, the information-seeking mantra. Third, even when data gets super complex and high-dimensional, we have powerful techniques to make it visible. And finally, by making our models visible, we make them understandable, we make them transparent, and ultimately, we make them trustworthy. Which really just leaves us with one last question to think about. Think about your own data for a second. What incredible insights, what hidden stories are just sitting there, waiting to be discovered, if you could only find the right way to see them? Hey, if you enjoyed this explainer and found it helpful, do me a favor and hit that like button, share it with someone who might find it useful, and of course, subscribe for more deep dives just like this one. Thanks so much for watching.